take a quick look here. So I'm not sure what the confusion on slicing, does it ignore acknowledge values mean? You can only slice by numbers, right? Because it's an index. So the only things that can be in a slice are yeah, of course. Somewhere in here I have CO2 levels. Yeah, we'll do L1. Okay, so if you want to look at the values in L1, they have to be integers, right? Indices have to be integers. So when you slice, you're slicing, you're specifying integers, or you're specifying indices. So they also have to be integers. I'm not sure what does it ignore acknowledge values mean. It doesn't, it just generates a sequence of indices and then extracts out from your list the values corresponding to those indices. All right. Okay, so I'm going to continue on now, I think. And I'm going to probably go through this a little quickly because most of this you guys can read for yourself. And we are trying to catch up a little bit right now. So you guys have been doing, you're on your third homework problem. You're starting to generate larger and larger programs. Here's some things you need to be able to do. When you start looking at your problem, think of the simplest way to kind of break it up. When I was doing the Pokemon one, what I really did first was I just wrote the loop to do 10 iterations, and I put some print statements in there. And then, maybe I added in the logic to force the Pokemon to go north, south, east, or west. And then as I developed through that, that's really the way I developed the program. Start with the basics, put in the stuff you need to read in, start putting in loops, and add the complexity. As you start finding things that you're doing over and over again, what you should start doing is you should start concentrating on encapsulating those in a function and pulling those out above your main code into where we want you to do functions. That will make it easy to read and modify, and it'll also keep you from making mistakes. If you find an error in code that you've repeated, you only have to fix it once. If you're always calling the same function, you need to fix it once and then it's fixed. Don't put in hard-coded numbers for things that you need to change. We always get this, how many comments should I have? Well, include comments for important things. All your functions should be commented, but you don't need to comment every line. Something like this doesn't really tell us much. We can read the code and see that it's incrementing X. We want assumptions on what's passed to a function. We want to know what the function does. And we want to make sure that we know what the return value is and make sure that there's no paths through your function that doesn't actually return a value if your function is meant to return a value. That's where those weird nuns come up. N-O-N-E, not any other none. You need to test. Get good at testing because SUMIDI will test it. And it's much harder to debug on SUMIDI than it is to debug on your own. So figure out what's going to break. Think about what cases you should be having in there, and then, test things, including typos that we are probably going to make intentionally in the SUMIDI input. If you're testing your code, that will work. Yes, James. You can, however, use those. Else, you can use. So the question is, we only use the triple quote comments for functions and descriptions of programs. You can use the smaller hashtags for other places. You're also allowed to use the block comments if you want. That's perfectly fine. I worked with a gentleman who we ran these huge dashboards running on hundreds of machines, and we still found errors in our code. And we would find out that we had code that wasn't touched by any of the test cases, and eventually something gets changed and that code broke, even if it was at some point correct. So if you aren't testing your code, if you're not forcing your execution through every line you wrote, then I can guarantee that if you do enough lines, if you have a sufficiently complex program, it will not work at some point for some input. So make sure that you run through and test for things that you don't think people are going to enter, because we're probably going to enter them. When you do, also, errors often compound themselves. If your program's crashing after 24 hours, don't try to, but it's spewing out hundreds of errors in the first 7 minutes. Look at the errors that come out in the first 7 minutes first, because they're going to be most likely accumulate to result in the crash. So fix the first error first, not necessarily the one that looks like the biggest. These things have a habit of cascading, and a small error may become a bigger error later. And there's a lot of ways to debug your program. There are some concepts you can look through those, use a debugger, comment out stuff, test parts of your code separately. This is really good for using, if you use functions that make this a lot easier, etc. All right. Quickly on the debugger. Hopefully you guys have been using the debugger a little bit by now, but let's quickly look at at some of this material. This is essentially the code that was in this body main. The only difference here is that there is this add to line, right? Instead of doing total equals total plus I, or total plus equals I, we've replaced it with this little function, and that's for a reason we'll show you in a little bit. But this is essentially the code that's in that little block there, and I can take out those and we can run this, right? If we hit the little green arrow, we're going to run it. It's going to ask us for an integer, say 78, and it's going to go through and it's going to tell us, after a bit, that the sum is 3003. All this is doing is it's going through a loop and it's adding the first n integers together. So if I put in 1, this should return 1, right? Or sum is 0. N minus 1, sorry. And if I put in 2 and just embedded an error, what is this doing? There we go. Okay, yeah, it's adding up the first n minus 1. If we put in 2, it adds up 0 and 1. We put in 1 and adds up 0 and 0. So we should be able to come down here. We should be able to do 10, and 10 should add up the numbers between 0 and 9, which would be 45. And it's really a pretty simple program to get to learn to use, or this pretty simple program, but we're going to use it to kind of show you how to do some debugging. These things run your code. These things help you debug. So we can start off that first button with the double vertical equal signs starts the debugger. And you notice that when it starts the debugger, it tells you we're up here on the first line of your program, which is, for this one, exactly a comment. Now we have some choices. If we hit this, we're going to run the current line. So we'll step through running one line at a time. And just like in Python Tutor, when we hit the definition of a function, all we do is make note of it. We hit this little guard, and I'll talk about that in just a minute. And we can look at name. And we can find out that name does in fact equal main. So we're going to drop into this program. And now we ask for a a positive integer, and I'll say 5. We enter it. So we're stepping through one line at a time using this program. And that works really good until you get to a point where you want to debug a function call. If you want to debug a function call, if you hit this, it steps right over the function call and executes that code. So now we have total. Total should still equal 0, I think. Okay. We'll increment I. But what if we really want to debug total? Well, we can use this call, right, where it has the same kind of arrow step, but it steps into. And that'll actually step into any functions that we're hitting. So now we can do things like look at, we can look at val. We can look at increment. And we can start going through and debugging our code to find out what's actually going on, what our program flow is. If this was a longer function, if this were a longer function, we can use this button to jump out of it. And that will take us to the end of that function so that we can go through and the next step will bring us back to the start of our code. There's 2 other buttons here. This button is a continuation. This will continue to the next breakpoint. So if we know where we have an error or we want to see what's going on a specific line, we can click over here in the margin and set a breakpoint. I'll set a breakpoint there, and I'll set a breakpoint here. So this will continue to the breakpoint, right? So the next one that comes up is add to total I, right? So we can look at total. We can look at I, and now we can maybe step over it this time and see what total is after that call. Total is 2 plus 1 equals 3. That's correct. So that's looking good. We can run again. We're at our breakpoint again. Well, we've kind of debugged this breakpoint. We don't want it anymore. We can click and make it go away. And if we hit the continue again, we will run to the next breakpoint, which happens to be outside of the loop, and we can look at things there as well. Okay? So the sum of the integers from 0 to 4, right? We put in 5, so we're going to go 0 to 4. Sum of the integers from 0 to 4 is, in fact, 10. This button stops debugging. You can see as long as this says IPDB, we're debugging. When we want to stop, we can do that. Now we're right back where we wanted to be, and we can run our code the way we want to. Okay. What else do we have in that section? So that's just a quick tutorial on how to do the debugger. Make sure you learn the debugger, and make sure you learn some other tricks as well. You'll notice that in this we have some print statements that tell us, when we enter our loop, what are our loop variable I, what's our loop termination variable N, and then we print that out every time so that we see that I is in fact progressing to N. If we had, for example, while I not equal to N, or greater than or equal to N, and maybe we start I out at N, right? Now we would actually see that we are in an infinite loop and life is horrible, right? So print statements can help you find things like this. I will say that if you're going to do a print statement as part of debug, I always like to do flush equals true. It will give you better, more accurate results, because that will print out the values as soon as it gets them, as opposed to queuing up a whole bunch of them and then printing them out and maybe missing the step that you're interested in. Okay. Int object is not callable is a general question, but you saw that when I did string today. When I tried to use the string function in my own code, turns out I had done something like string equals 5. All right, whatever I did, I broke it now. and then I had to restart the kernel. You did something similar. You assigned something to the value int, to the variable int. All right. What's the next thing we want to talk about today? Okay, so hopefully that gives you a little bit of insight into that, into what's going on. What else do we have to hear? Okay. All right, got a lot to cover. I want to talk about this briefly. This is code organization. Use functions, and use functions to encapsulate stuff to help your main be simple, right? So if you're doing something over and over again, make it a function. It'll help you out. Don't make a function that does everything. Make a function that does one well-defined task. If you don't do that, you end up with code that is just as functional code that's just as hard to debug as the main. We also want you, right, from now on, homework 4, you don't have to worry about it for homework 3, but for homework 4 and 4, we're going to start working with modules. I think modules actually come in 5, but we're going to start working with modules. And you'll notice that I have a little thing in here that says if name equals main. We want you to start using that. Your functions, your imports should be first, then your functions, you should have a guard, and then you should have your main. And the reason for this is, well, anything you write in Python can be considered a module. This is a module called Lecture11 module. And all this module does is it defines, a really stupid function that takes a value and an increment and adds the increment to the value. Def add to val increment, return val and increment. And the whole purpose of this module is to do this, is to provide this function. What we've done is down here is we've put in code that we can execute that tests the functions that we want to export. And we've protected these with this guard. So if we're in this file and we run, right, and we already demonstrated this, it's going to define something called name underscore name, 2 underscores. And that name is going to be equal to main because we're running here. This is the main program that's being run. And we step through here, what we're going to find out is that we actually go through and execute the code down below. Right? But it's also possible that we take this code, and I'm going to stop debugging because it's boring. We take this code and we call it from someplace else. So if we want to call it from someplace else, what we want to do is we want to import Lecture11 module. That's the name of the module. And then we want to be able to call our Lecture11 module add to. When you call a module, anything that's not contained within a guard, within this particular guard, is going to get executed. When you call a module, when we hit this import, it's going to read in and execute everything in this file. And remember, when you execute a def, all it does is make note of where the function is so it can get back and call it. So this doesn't actually do anything. If we put a line here like print howdy, right? That's now outside of the guard. So when we come into main and we run through our main, let's debug our main, right? And we step down through. When we step and do the import, we're going to read in that entire module and we're actually going to print out howdy. Now at the same time, we've also defined no help there. Why is that? Probably because we don't have any comments. We should have. Okay, and in any event, that may be because I'm in the debugger. There you go. Okay, it was because I was in the debugger. Okay, so what? Okay, so when we call this, when we do this import line, we're actually going to execute, and we can come in here. Let's actually put a breakpoint here. Right? We can actually see the execution of our module. It executes that first line. It executes the print howdy. It hits the block, and it's done. Right? And then we're going to come back, and we're going to run until we hit our next breakpoint, at which time we've already printed out our 12, and then we'll print out our end. Okay? So there we go. Let's see what the next thing we want to talk about today is. All right. So just be careful of that. We want you to start using that. After that, then you put the rest of your code. You know, and again, when you're doing your main code, prioritize input. Try to put your input first. Put your loops. Put your execution. Okay. And use, when you write a module, and we're going to ask you to write modules, use the code within that block, within that guard, to actually test your code and make sure that it works. And you'll have a lab on that too, by the way. That's kind of fun.